Ravi, Revati, Kavita, anybody?
Yes. So
Yeah,
is my
let's
screen
start.
visible, sir?
Yeah, it's visible. Yeah, please go ahead.
Okay, sir. Good evening, everyone. We are Group 2 from MSc Statistics, and we are here to present on a project. Our topic being medical insurance premium prediction. Our team is of 6 members, namely Chavi, myself, and my teammates Supriya, Kavita, Sushma, Revati, and Yamini. Abstract of our project is: the study emphasizes the growing need for effective predictive models in the healthcare industry to anticipate medical insurance costs due to rising expenses and complexities. It focuses on using machine learning techniques to forecast insurance premiums, helping patients estimate their medical expenses and claims. Objective: the objective of the project is to build a machine learning model to forecast annual medical insurance premium based on given customer data. We will proceed with our presentation as follows. First would be introduction to medical insurance, literature review, history and background for the same, data set overview, data pre-processing, exploratory data analysis, multicollinearity check and significance test, machine learning algorithms, conclusion, summary, and work distribution. So what exactly is medical insurance? Medical insurance is a type of insurance that helps people pay for healthcare expenses. When you have medical insurance, you pay a company called as an insurance company a certain amount of money regularly, usually every month, which is called as premium. In return, if you get sick, injured, or in need of any medical care, the medical insurance that you have taken from the insurance company will help you cover some or all of the cost of your medical treatment. There are various types of medical insurances like individual health insurance, family float health insurance, senior citizen health insurance, critical illness insurance, and group insurance. There are many benefits of receiving a medical insurance like protection against unexpected medical expenses, access to quality health services. Then it is also cost saving as it gives tax benefits and also incentives for maintaining healthy lifestyle. Next will be continued by my teammate Supriya.
Thank you, Shri. My name is P. Supriya, and I'm presenting on literature review. First, A. Kalfan, Asan, and M.S. Ansari, they have done the research on machine learning techniques for predicting insurance premium. And this is an abstract of them. This study investigates various machine learning models for predicting insurance premiums like gradient boosting and neural networks. And in their work, they specifically focused on developing predictive models which uses a history of data to predict and to forecast the insurance premium accurately. And some of the machine learning techniques that they use for this research are linear regression, decision trees, random forest, etc. So from the research, they concluded that these machine learning techniques are highly effective for predicting these health insurance premium prediction. Second, R.S. Raj and S. Kumar research. They have done the research on deep learning approaches for health insurance premium prediction. And this is an abstract of them. So this paper explores the application of deep learning techniques, which includes convolution neural networks and recurrent neural networks for health insurance premium prediction. So in their research, some of the key findings are improved accuracy for high risk policyholders, potential for personalized pricing, importance of claims data, and also handling the high dimensional data. So from their research, they summarized that these deep learning approaches are highly effective in predicting the health insurance premium. Specifically, they said that the claims data is crucial and deep learning can handle the complex data. S. Gupta and S. Sharma research. They have done the research on predicting health insurance premium, comparative study of machine learning, and this is an abstract. So it analyzes the impact of different feature sets and pre-processing techniques on predictive performance. And they summarized from their research that the gradient boosting is the most suitable algorithm for health insurance premium prediction because it is providing high accuracy and also robustness. whereas linear regression and decision trees may not be the best choices for predicting the prediction because it is providing a low accuracy. Now, Sushma will continue.
Thank you, Supriya. I'm Sushma. I'm presenting history and background. Medical insurance was launched in 1986. The medical insurance industry was grown significantly mainly due to the liberation of the economic and general awareness. Healthcare insurance, health insurance India is growing segment of Indian economy. The Indian healthcare system is one of the largest the world. The healthcare industry in India has rapidly become one of the most important sectors in the country in terms of income and their job creation. Next, policies are available that offer both individual and family coverage. The NSSO releases the report Key Indicator of Social Consumption in India Health based on its 71 rounds of surveys. The survey carried out in the year 2014 found that more than 80% of Indians are not covered under any health insurance plan. Only 80% of the urban population and 14% of the rural population are covered under any form of health insurance. The General Insurance Corporation of India and the Insurance Regularity and Development Authority launched an awareness campaign for all segments of the population. Thank you. Next, continue by Kansa.
Thank you, Sushma. This is Kavita, and I will continue on data pre-processing and EDA part. Dataset overview. Source: the dataset, that is secondary data, was extracted from Kaggle. And about ACME Insurance Company offers affordable health insurance to thousands of customers all over the United States. Here we are creating an automated system to estimate the annual medical expenditure for new customers. And it is used to determine the annual insurance premium offered to the customer. And next, variables. The dataset contains 7 variables, namely age, sex, BMI, children, smoker, region, and charges. We have the data of 1,338 individuals who have taken medical insurance. And next, data preprocessing. Data preprocessing is the process of transforming raw data into clean and standardized format that is easier for machines to understand and use in analysis and model training. Here, the categorical variables, namely sex, smoker, and region, were converted into numerical form using dummy variables. And under dummy variables, the region variable was converted into 3 variables based on the data set. And the data set was checked for missing values. Here we have no missing values. And next, EDA part, exploratory data analysis. It is a data visualization to identify the patterns, connections, and relation between the variables. The first one is pie charts. The first pie chart shows the sex ratio in the data set is almost equal for male and female, that is unbiased. And the second pie chart shows the ratio of smokers is higher than the ratio of non-smokers in the data set. And the third pie chart shows the data set that around 85% of the insured are having less than 3 children. And the second one is bar plots. The first bar plot shows the relation between region and count. The insured belonging to the southeast region is slightly higher than the other regions in the data set. And the second bar plot shows the relation between charges and count. The insured being charged below average is more than the above average. And it shows the positively skewed data. And next, scatter plots. The first scatter plot shows the relation between smoking status and charges. The premium charged for smokers is higher than the premium charged for non-smokers. And the second scatter plot shows the relation between gender and charges. The premium charged for males and females are almost equal, showing that premium charged is not affected by gender, that is unbiased. And next, correlation matrix. Here it shows the highly correlated variables. Those are charges and smoker S. There is high positive correlation between charges and smoker S variables, that is in thick red color, dark red color. And next, pair plots. The pair plot shows the charges on y-axis, that is one dependent variable charges, and on the x-axis there are 7 independent variables. Next will be continued by Revati.
Thank you, Kavita. I'm Revati. I will continue with multicollinearity and significant tests. Multicollinearity. In first table, we include all the variables and we observe that BMI have VIF score more than 10. In second table, we remove the BMI which have more than 10 and we observe the VIF all are less than 10. In third table, we remove the insignificant variables and we observe that VIF are less than 10. Model 1. In model 1, we include a complete data set and we observe the p-value. We can observe that 4 variables have p-value more than 5%. Second model. In second model, we remove the multicollinear variable and we observe the p-value. The p-values are less than 5 except 4. In the third model, we remove the insignificant variables and we observe the p-values which are almost everything less than 5%. In fourth model, we remove all insignificant variables as well as multicollinear variables and we see that p-values are less than 5%. Next slide will be continued by Yamini.
Thank you, Revati. I'm Yamini from Group 2. Now I'm presenting about machine learning algorithms. Here we are using 4 models. That is, model 1 is we are using complete data set and model 2 is data after removing multicollinearity and model 3 is data after removing insignificant variables and model 4 is data after removing both multicollinearity and insignificant variables. Here we are taking the train test splitting ratios, sir. 60 is to 40, 70 is to 30, 75 is to 25, 80 is to 20 and 90 is to 10. Here we are using machine learning algorithms are multiple linear regression, k-nearest neighbors, support vector machine, decision tree regressor, random forest regressor, bagging on decision tree regressor. Here first we are taking 60 to 40 train test split ratio. In that model 1, random forest is giving highest R square value that is 0.83 and lowest root mean square error value that is 4980.66. And in model 2, linear regression is giving highest R square value that is 0.70 and root mean square is giving lowest and linear regression is giving lowest root mean square error value that is 6524.69. And in model 3, bagging has highest R square value that is 0.83 and lowest root mean square error value that is 4928.13. In model 4, linear regression having highest R square value that is 0.70 and lowest root mean square error value that is 6514.23. Next we are taking the ratio 70 to 30 train test split ratio. In that model 1, random forest is giving highest R square value that is 0.83 and lowest root mean square error value 4922.84. In model 2, linear regression giving highest R square value that is 0.707 and lowest root mean square error value that is 6443.53. And in model 3, bagging giving highest R square value that is 0.83 and lowest root mean square error value that is 4854.19. And in model 4, again linear regression giving highest R square value that is 0.70 and the lowest root mean square error value that is 6455.40. Next, 75 to 25 train test split ratio. In that, Model 1, random forest regressor is giving highest R-square value that is 0.82 and lowest root mean square error value that is 4925.91. And in model 2, linear regression giving highest R-square value that is 0.70 and lowest root mean square error value that is 6373.60. In model 3, bagging giving highest R-square value that is 0.82 and lowest root mean square error value that is 4898.67. And in model 4, linear regression having highest R-square value that is 0.699 and root mean square error value and lowest root mean square error value that is 6385.05. Now we are taking 80:20 train test split ratio. In that model 1, random forest giving highest R-square value that is 0.85 and lowest root mean square error value that is 4775.07. And in model 2, linear regression having highest R-square value that is 0.727 and lowest root mean square error value that is 6383.51. And in model 3, bagging giving highest R-square value that is 0.86 and lowest root mean square error value that is 4644.01. And in model 1, again linear regression is giving highest R-square value that is 0.725 and lowest root mean square error value that is 6400.02. Here again, now we are taking 90:10 train test split ratio. In that model 1, again random forest is giving highest R-square value that is 0.84 and root mean square error is and lowest root mean square error that is 5028.52. In model 2, linear regression is giving highest R-square value that is 0.689 and lowest root mean square error value that is 7004.28. And again in model 3, bagging has highest R-square value that is 0.84 and lowest root mean square error that is 5088.65. In model 4, linear regression is having highest R-square value and root mean square error and lowest root mean square error value that is 7024.01. After comparing all algorithms, the model 3 is the best model. And bagging, it has highest R-square value that is 0.86 and lowest root mean square error value that is 4644.01. Conclusion. Based on our dataset, we observed that model 3, that is the model with only significant variables, has been giving high R-square values with low root mean square error. The highest R-square value with a low root mean square error was observed while using the decision tree algorithm after bagging. Hence, we conclude that the model that can forecast annual medical insurance premiums based on the data is model 3 using decision tree regressor algorithm after bagging using 80:20 train test split ratio. Summary. Machine learning may increase the efficiency, fairness, and accuracy of the insurance industry by creating prediction models and evaluating historical data. However, challenges include ensuring fairness, transparency, mitigating bias, and maintaining model interpretability. Despite these advancements in machine learning techniques and a deeper understanding of insurance dynamics are paving the way for more understanding. And here is the work distribution done by group 2. Thank you, sir.
Very good work,
Okay.
Adam. Yeah, sorry, Palak, you're saying something? Go ahead.
Yes, so group 2, just one quick question. All of you are present now today?
Yes, sir.
Sorry?
Yes, sir. All of us are present.
Okay, fine.
Nice. No, very well done. Excellent. Again, the same thing, explaining the entire context of healthcare industry, how insurance industry works, giving a background about about it before you start working on the data set and analysis. was very, very helpful. So very good, again, presentation, analysis, and everything. In general, my question would be, in your case, you're lucky not to have any missing values, isn't it? But if it were, if you had some missing value, what would you have done?
So it would depend on the number of missing values that we had, sir. If the missing values of were only a few numbers like 1 or 2, which would not affect the data, then we might remove the missing values. Otherwise, if there are a very high number of missing values, then we would either go for mean of the data if it is for in case of continuous variables, or maybe mode of the data if it is in case of categorical variables, sir.
Very good, nice. Over to Pradipta sir.
Yes, actually, it is a very nice one, nice presentation, as we have already seen from the very beginning. You have done an excellent work while creating these models, and also this presentation is very well decorated and well articulated, and the presentation among the way you presented it, the smoothness,